Hello, today we're going to be going over how to use long division with polynomials. I know you guys have seen long division in the past, but we can do a quick review of it. It really shouldn't be so much, back in 4th grade. But in general, when we're doing long division, we'll take our first term, which in this case was our 4. We divide it by 25. But 25 does not go into 4, so we have 0. Bring our 0 down, subtract it. 4 minus 0 gives us 4. Then we bring down the 2, so we have 42. 42, this is our new number we're going to divide by. So 42 divided by 25, which we have over here, gives us 1 with a remainder of 17. I think that 17 might not quite be in the capture, but it's over there. So when we subtract 45 minus 25, gives us that 17. We bring down our last number, which was our 5, and we divide for one last time. 175 divided by 25 gives us 7. So 425 divided by 25 is 17. Nothing too crazy, but I just thought it was a good idea that we should review this a little bit since we're going to be using it with polynomials. Another review is you guys should in Algebra 1 have divided by monomials, but we'll do a little review for it. So when we divide by monomials, we can divide this bottom piece by each piece on the top. So if we break it up, for our first piece we'll have 25 x squared divided by 5x. I apologize in advance for the handwriting. I am writing with a mouse right now. Not the most ideal. So don't forget our subtraction sign. So minus 10x divided by our denominator of 5x. Now that we have separated, we can divide each piece by 5x. So 25 divided by 5 gives us 5. And x squared divided by x gives us x. If we don't remember, when we are dividing exponents, all we are doing is subtracting the powers. So if we have 2 x's on top, x squared, one cancels out with the 1 on the bottom, or 2 minus 1 gives us 1. Okay, and for our second piece, subtraction stays. 10 divided by 5 gives us 2, and our x's cancel, because 1 minus 1 is 0, x's power is just 1. So we're left with 5x minus 2. This is for dividing by monomials. Monomial just means one term. Mono, like mono, one on one term. All right. So, can move on, and I'd like you guys to take a second, pause the video, try this, a little bit of review. Give like 2 seconds in here for you to be able to pause, and we'll go over it. So, dividing by monomial, all we're going to do is break it up into our 3 pieces. So our 15x cubed gets divided by 3x, our 9x squared gets divided by 3x, and our 12x gets divided by 3x. Dividing each piece, 15 divided by 3 gives us 5. Dividing the x's, 3 minus 1 is 2. 9 divided by 3 is 3. X squared divided by x, 2 minus 1 is 1. 12x divided by 3 gives us 4, and x divided by x cancels out, and we're left with nothing. All right, now is when we start to get a little bit more interesting into new stuff. So we're going to look to divide by a binomial. So binomial means bi, like a bicycle, is 2 terms. It's something you've probably already heard a good amount in math, but you're going to hear a lot more. So this is where we're going to start using long division. So when we have long division, we'll take our numerator, just like the top number we divided by before. we have x squared plus 5x plus 6. So we're going to have like carpal tunnel or something from this. And on the outside's our denominator, or x plus 2. Now, long division with binomials, or any polynomial, it's very similar to long division that you did in elementary school. But it's a little different. So the first thing we're going to do is we're going to divide the first term by the first term we're looking at. So x squared divided by x gives us x. This x is what goes on top, just like when we divided by it before. But now, when we're, here I can go back up real quick. So after we divided, we would subtract by whatever we put on top times the front, right? So what we're going to do is we will take the x we just got, and we're going to multiply this x times everything over here, every piece. All right? So x times x will give us x squared, and x times 2 will give us 2x. Now, just like beforehand, the old long division, we were subtracting this number, right? Same thing here. We're going to be subtracting this. So this part is probably the part that most of you guys are going to make a mistake. Just get that negative on the outside, and what it does, it flips everything on the inside, just distributing that negative. So it's the same thing as we're going to have minus x squared and minus 2x. All right. So x squared minus x squared, will give us 0x squared, or 0. 5x minus 2x will give us a positive 3x. And just like in long division from when you were younger, we bring down the next number, which is plus 6. Okay? And we repeat the same process. So we will take our, look at red again, 3x divided by our x. So 3x divided by x is equal to 3. So we have a positive 3, so plus 3. And now we take this number on the top, our 3, and we multiply it by every piece inside here. So we have 3 times x, which gives us 3x. And then we have 3 times 2, which would give us plus 6. And just like before, we are subtracting this. Let me extend this slide real quick. We are subtracting it. So 3x minus 3x gives us 0. 6 minus 6 gives us 0. So 0 plus 0 is just 0, which is good. That means we have no remainder. Just like when we were little, if it comes out to 0 at the end, that means we have no remainder. So that gives us, so we're done. Our top here is our answer. So x squared plus 5x plus 6 divided by x plus 2 gives us x plus 3. And if we wanted to check this, we could multiply the top by the side, and it'll come out here. This is pretty much, it's kind of like factoring, what you guys did last year. It's just another way of breaking down if we know one of those factors. But we can also do it with numbers that don't go in perfectly with remainders. We won't worry about that too much today, though. But if this was not a 0 at the end, it would not go into it perfectly, and it would not be a factor. So if, I guess I could type this. So if there is a 0 at the end, the divisor is a factor of the numerator. All that means is if there's a 0 at the end when we're dividing, the number we divided by is a factor of the number we're dividing into. All right? And if it's not the case, that's not true. All right? So let's do another example. Now, let's pick this example specifically. Oh, I don't want to put an equation in. We picked this example specifically because if you notice in our last examples, we had x squared, x, and then a number. In this one, we don't have any number in between. So that kind of changes it, but not too much. So let's look at our equation again. Boop, boop. So we have our x squared minus 1, the numerator at the top, divided by x plus 1, or the denominator or divisor. Number goes on the outside. Okay, so we look at our first number, which is our x squared. It's divided by our first number of the divisor. So x squared divided by x. 2 minus 1 gives us 1x. So we have x. So x goes on the top. Okay. Now, x times, I'll do it here. So the top number here times everything over here. So x times x gives us x squared. X times 1 gives us a positive x. And all of this is going to be subtracting. Now, take a second, try to figure out if you can see what our problem is. Any of you see it? So, if you notice, this minus 1 and this x, they don't share like terms. So we can't subtract them. That's the difference when we're not counting down precisely. So we have no x term in here. So what we do is we're gonna make one that doesn't change the value of this equation. So I'm gonna move my minus 1 over. And something that wouldn't change the value of the equation but gives us an x would just be adding 0x. And let me put a little bit more space on that erase there. Okay, so now we can keep doing what we were doing before. We just have our subtraction now. X squared minus x squared gives us 0x minus x. Don't forget our negative on the outside. Gives us minus x. And we bring down our negative 1. Okay. So we do continue the process. We divide our first number here. I guess we can use red again. This number divided by first number what we're dividing by the first number of the divisor. So we have, once again, so we have negative x divided by x, which gives us negative 1. So we have a negative 1 on the top. Okay. Now we take our negative 1 and we multiply it to everything on the side. So let me put this up here. This is where you're going to have a little bit of an issue. Just tracking all the negatives. So remember, everything we're going to have is going to be subtracted. So we'll deal with this negative before we end up working with all of it. So our x plus 1 times negative 1. So x times negative 1 is minus x. Negative 1 times 1 will be minus 1. And our negative distributes. So we will end up with plus and plus. So negative x plus x, 0. Negative 1 plus 1, 0. So we are left with 0. And if you remember from our last example, that means that x plus 1 is a factor of x squared minus 1, which will be important later. But for now, it means that x minus 1 is our answer. And x plus 1 times x minus 1 is equal to x squared minus 1. All right. Now, I want you guys to take a second, try this one yourselves. And pause it now, and we'll go over it. So, same idea. We take our x squared plus 2x plus 1, it's our numerator, and we have our denominator on the outside. If we slowly follow each step, x squared divided by x gives us x, x times x squared, x times 1, x, subtract down, we get x plus 1, follow the process, and it comes down to 0. So, x plus 1 times x plus 1 gives us x squared plus 2x plus 1. The reason I picked this example is some of you may recognize this as an easily be factorable binomial, which would come out as x plus 1 times x plus 1. But if we divide it out, x squared plus 2x plus 1 divided by x plus 1 is equal to x plus 1. All right. So the last thing that we are going to cover today, so I want to show you that the reason we use long division is because it works with any polynomials. Even though it can be a pain in the butt, it works. It's kind of like the completing the square quadratic formula, which you may have learned in Algebra 1. It can be a pain in the butt compared to factoring, but it always works. So we're going to do it here with a little bit larger of a number, or a polynomial. By the way, poly means many, so it's just going to be any number of terms. So technically, all the monomials, the binomials, trinomials, all those are all polynomials. Polynomial just means the general term. So in our case, we're working with a trinomial on the bottom and a 5th degree polynomial on the top. By degree just means how many terms. Okay, so let's put this in. The numerator goes underneath it. So 2x to the 4th plus x cubed minus 9x squared minus 5x minus 5. Ooh, I do not like writing with this mouse. Alright, denominator goes on the outside. We get 2x squared plus x plus 1. Okay. This does look a little bit scarier, but it's the same process we have to follow. So we take the first number, our 2x squared. I guess I should say first term, not first number. We take the first term on the inside. So we have 2x to the 4th divided by 2x squared gives us 2's cancel, 4 minus 2 is 2, so we have x squared. So x squared goes on the top. There we go. That is a 2, I swear. Why don't I rewrite that? That's pretty bad. Okay. Now, we take our x squared we just got, we multiply it by every piece. This is all going to be subtracted. So we're going to put up our parentheses. We're going to have 3 terms. It's going to be subtracting. X squared times 2x squared gives us 2x to the 4th. These pretty much should always cancel out, by the way. That's why we're dividing it, make it cancel. Alright, x squared times x would be plus x cubed. Okay. X squared plus 1 would be plus x squared. Alright. I'm going to distribute the negative just to make it a little easier to see. This negative is going to go to every piece. So we have minus 2x squared minus x cubed minus x squared. I think I said x squared here. It should be x to the 4th. 2x to the 4th minus x cubed minus x squared. Let me extend this page because we're going to need it. Okay, so subtracting here, 2x to the fourth minus 2x to the fourth is going to cancel out, so we're left with 0. You don't have to write these zeros, by the way. I'm just writing it. Like in my work, I would not be writing these, but I just want to show visually, make it a little easier. X cubed minus x cubed will give us 0. 9x squared minus x squared will be minus 11x squared. Okay, and then we're going to bring down the next term, which will be minus 5x. Okay. Whew. And why don't we, yeah. Okay, and by the way, you didn't know, these will be these x to the fourth and x cubed terms. They're just 0, so we weren't worrying about them. Okay, so next term, we look at our first piece we have here. So we have negative 11x squared divided by 2x squared. So negative 11x squared divided by, oh, should be a 10, not 11. Point that out now before we go further. 9 minus 1 is 10, not 11. Little oopsie-daisy there. Good to catch your mistakes early if you can, because that could have messed us up. So, negative 10x squared divided by 2x squared. This is equal to negative 5. 10 divided by 2 is 5. Negative stays. Negative divided by positive is negative. X squared divided by x squared cancel out, so we're left with minus 5. And could put it over here, but might be, yeah, we can just leave it there. If you wanted to, you could put it further down the line to make it a little bit visually a little nicer, but we don't need to. So we take our minus 5, we multiply by everything in the front. Same process, just over and over again. So this is all going to be subtracted. All right. Okay, so negative 5 times 2x squared will be negative 10x squared. Okay. Negative 5 times x, negative 5x. Negative 5 times 1 will be negative 5. By the way, this should be down here as well. Dragging the whole thing down so that we have a term to subtract from. And then conveniently, if you can see it already, when we distribute this negative, these all become pluses. Why don't we do that in a different color? So we'll do that with red. Distribute our negative, turning all of our negatives into positives. And 10x squared plus 10x squared, or negative 10x squared plus 10x squared would be 0, plus negative 5 plus 5x would be 0. Negative 5 plus 5 is 0. So we come out and we have no remainder. So our answer is going to be x squared minus 5. All this means is 2x squared plus x plus 1 times x squared minus 5 will give us the numerator. Or when we're looking for our answer, if we divide our numerator by our denominator, we get x squared minus 5. Okay, we'll practice more of these in class. You guys have a great rest of your day.